How does freezing differ? Solutions versus pure substances. Have you ever wondered why adding salt to ice makes it colder? This question leads us to an interesting topic: how freezing differs between solutions and pure substances. Let's break it down. Freezing is the process where a liquid turns into a solid when cooled to a certain temperature. For pure substances, like pure water, freezing occurs at a specific temperature. This temperature is the freezing point, where the liquid and solid forms exist in balance. At this point, the vapor pressure of the liquid equals that of the solid. Now let's consider pure water. When it cools to 0 degrees Celsius, it freezes. This is a sharp transition. The temperature remains constant during the freezing process until all the water has turned to ice. In contrast, when we look at solutions, things change. A solution is a mix of a solvent, like water, and one or more solutes, like salt or sugar. The presence of solute particles affects the freezing point of the solvent. This phenomenon is known as freezing point depression. When solute particles are added to a solvent, they disrupt the formation of a solid structure. This means that the solution must be cooled to a temperature lower than the freezing point of the pure solvent to freeze. For example, when salt is added to water, it lowers the freezing point. This is why salt is often used on icy roads in winter. The saltwater solution must be cooled below 0 degrees Celsius to freeze. The solute lowers the vapor pressure of the solvent. Since freezing occurs when the vapor pressures of the liquid and solid match, this reduction means that equilibrium is reached at a lower temperature. Additionally, solute particles increase the disorder in the liquid phase. This higher disorder makes it harder for the solvent to organize into a solid. Therefore, a lower temperature is needed to achieve solidification. In practical terms, this is why substances like antifreeze are added to car radiators. Ethylene glycol, for instance, lowers the freezing temperature of the coolant, preventing it from freezing in cold weather. Mathematically, we can express the change in freezing point using the formula. Change in freezing point equals negative constant times molality. The constant is specific to the solvent, and molality is the concentration of solute particles in the solution. To sum it up, pure substances freeze at a fixed temperature, while solutions freeze at lower temperatures due to the presence of solutes. Understanding this difference is essential in thermodynamics and has practical applications in everyday life.